Welcome to a surprisingly short video, two-sample inference. So I'm just going to talk about the differences from one sample, and I'm going to bring in the idea for matched pairs. So not a lot changes, honestly. For hypothesis test, we're going to alter our statements to discuss two different proportions or means. So let me write the word or means. I don't know why I didn't write it. For confidence intervals, we can make stronger conclusions. For instance, if 0 is in the interval, it's plausible that there is no difference. For both intervals and tests, we just have to check conditions for both samples. We also need to add that the populations must be independent, right? So not only can the samples be random, but they must come from independent populations. That's really the big difference. It's basically the same test though. You're going to press a different button in your calculator. You'll do two sample t-test or two proportion z-test. Also, there is a matched pairs thing. Matched pairs only applies to means. If we have two sets of data from a single population, we're not going to do two sample procedures. We're going to do one sample procedures on the set of differences. That's all the notes. I just got a couple problems to talk about. Manufacturer claims its brand A battery lasts longer than its competitor's brand B battery. 9 batteries of each brand are tested independently, and the hours of battery life are shown in the table below. Provided that the assumptions for inference are met, which of the following tests should be conducted to determine if brand A batteries do in fact last longer than brand B batteries? Well, this is talking about means, so it has to be a t-test. We know that. It has to be t. We can get rid of these z's. Now, I need to think, is this matched pairs or is this two sample? Did they sample from one population or two populations? Well, these are two distinct populations. One is brand A, one is brand B. So it's not going to be a paired test. Now we got to determine, is it one-sided or two-sided? Well, it's saying, do they last longer, right? That's giving me the idea of a direction. So that's going to be one-sided. A randomized experiment was performed to determine whether two fertilizers, A and B, give different yields of tomatoes. A total of 33 tomato plants were grown, 16 using fertilizer A and 17 using fertilizer B. The distributions of the data did not show marked skewness, and there were no outliers in either data set. That's basically saying, hey, conditions were met. Cool, wink, wink. The results of the experiment are shown below. Which of the following statements best describes the conclusion that can be drawn from this experiment? So these are all basically just asking what's the p-value. And they gave you plenty of information to figure that p-value out. So if you go in your calculator and do the two-sample test, you should find the p-value, which will take you to your answer. I'm going to So then when we run the test in the calculator, remember our alternate hypothesis is going to be not equal to, because we're just testing for a difference. The p-value is 0.016. So I just got to find the right interval for that. And that's D. That's it. A survey organization conducted telephone interviews in December 2008 in which 1,009 randomly selected adults in the United States responded to the following question. At the present time, do you think television commercials are an effective way to promote a new product? Of the 1,009 adults surveyed, 676 responded yes. In December 2007, 622 of 1,020 randomly selected adults in the United States had responded yes to the same question. Do the data provide convincing evidence that the proportion of adults in the United States who would respond yes to the question changed from December 2007 to December 2008? So these are, in fact, two different populations. We have a population of adults in 2007 and a population of adults in 2008. So this is going to be two sample procedures. It's not going to be matched pairs. So I'm going to do my state. So the null hypothesis is that mu1 minus mu2 is equal to 0. Or sorry, this is proportions. Who am I? P1 minus P2 is equal to 0. And the alternate is P1 minus P2 is not equal to 0. Because all they said was, is there a difference? Did it change? Where P1 is the proportion of US adults who would respond yes in 2007 or 2008, it doesn't really matter as long as you're careful with your hypothesis statements. logo 2008, and P2 is the same in 2007. There, state is done. Plan. We will conduct a two-proportion z-test. Both samples are random, and the populations are independent. Let's hit them with a little 10%. We know that there were at least 10,200 U.S. adults in December 2007. And at least 10,090 in December 2008. Now we got to hit them with some large counts because we need the sampling distribution to be approximately normal. So N1 P hat 1 is 676, right? So did I say 2007 or 2008? Yeah. So 676. Which is greater than or equal to 10. N1, 1 minus P hat 2, P hat 1 is going to be the rest of them. Which is 333. N2 P hat 2 is equal to 622, which is greater than or equal to 10. So I'm just looking down at the iPad. That's 398, which is greater than or equal to 10. So the sampling distribution is approximately normal. That was a lot, but conditions are now done. Now we're going to go on to the do. Remember, the do is always in the calculator for you. I just got to run it, so give me a second. Okay, I'm back. Z equals 2.82. P-value is equal to 0.005. All right, now I make a conclusion. At alpha equals 0.05, we definitely reject, right? They didn't give us an alpha, so we're going to use alpha equals 0.05. So we reject the null hypothesis. There is enough evidence to conclude that the proportion of U.S. adults who would respond yes to the question. I'm basically restating the last sentence in the prompt. To the question changed from December 2007 to December 2008. That's it. I'm out. Peace.